Hey, welcome back. I'm going to have you pause the video while you work out this problem on your dry erase board or on scratch paper, and then you can resume the video once you've given this problem a try, and we'll go over it together. So if we want to evaluate the sine of 7 pi over 12 times cosine of 5 pi over 4, we're going to need this product to sum identity, sine of alpha times cosine of beta. So 7 pi over 12 will be our alpha angle, and cosine, the 5 pi over 4 in our cosine function will be the beta in the identity. So we'll take 1/2 times the quantity sine, and then we need to add alpha plus beta, so that's 7 pi over 12 plus 5 pi over 4, and when we go to add these angles together, we're going to need a common denominator, and that common denominator for 12 and 4 is 12. So I had to multiply 4 by 3 to get 12, so I multiply the numerator by 3 to get 15 pi. So 5 pi over 4 is equivalent to 15 pi over 12. Now I've got a common denominator, and I'll be able to add those angles together in the next step. And then we have plus sine of the difference of alpha and beta, and that's going to be 7 pi over 12 minus 15 pi over 12. Okay, so simplifying now, we have 1/2 times the quantity sine, and then 7 plus 15 is 22 pi over 12, and then 7 minus 15 is going to be a negative 8 pi over 12. Okay, these are even, 22 and 12, so we can reduce that angle to be 11 pi over 6. And same thing for negative 8 pi over 12. Let's fix that, 11 pi over 6. Negative 8 pi over 12, those are both even, so we can divide out a 4, and we'll have negative 2 pi over 3. But remember, we have an even-odd identity for sine. Sine is an odd function, so that negative can come out to the front. So this will be sine of 11 pi over 6 minus the sine of positive 2 pi over 3, using that odd identity. So now we can look for those angles on the unit circle. So 11 pi over 6 is in quadrant 4. The sine is the y value, the y coordinate at that angle, which is a negative 1/2. And then sine of 2 pi over 3, 2 pi over 3 is in quadrant 2, and the sine is the y coordinate there, which is a positive square root of 3 over 2. So now when we subtract these fractions, they already have a common denominator of 2, so we'll have negative 1 minus square root of 3 in the numerator, and that's over our common denominator of 2, but we're multiplying by 1/2, and 2 times 2 is 4. So this will evaluate to negative 1 minus square root of 3, all divided by 4. We can check that answer by comparing the decimals from the original and our answer. So we make sure we're in radian mode, and we're going to compare the sine of 7 pi over 12 times the cosine 5 pi over 4 to our answer, which was -1 minus the square root of 3, all divided by 4. And we get the same decimal, so we know that we did it right.